Okay, so today we are going to do inverse trigo. Inverse trigo is basically in the inverse of trigonometry, of course. So that means that all the trigonometric identities, sin x, cos x, tan x, sec x, cosec x, they all have an inverse. They all have an inverse. Sin inverse exists, cos inverse exists, tan inverse exists, sec inverse exists, cosec inverse exists. Now I'm going to teach you how to, how to transition from one inverse trigonometric identity to another. So suppose sine alpha equals to x, or rather let's not. Let sine inverse x equals to alpha, because sine x will be uh, sine. In this case, sin x will give us a ratio. So the inverse of that ratio will give us an angle. So sine inverse of x, where here x is a ratio, it will give us an angle. So we can write it as sine alpha equals to x. Now if we want to shift from sine inverse x to cos inverse x, there is a formula of that sine states sine inverse x is equals to cos inverse 1 minus x square. But why does that exist? I'm going to tell you now. So suppose sine inverse x is equals to alpha. That means sine alpha is equals to x. Now we are going to draw a triangle. This is alpha. Sine alpha is equals to x. That means sine inverse is what? Perpendicular by hypotenuse. That means x by 1. So perpendicular will be x, hypotenuse 1. And then we can use Pythagoras theorem to find out this, which is going to be root over 1 minus x square. If this is something such, say, let's say y, then x square plus y square equals to 1 square. So we can write it as y square equals to 1 minus x square, and therefore y is equals to 1 minus root over 1 minus x square. And then cos alpha will thus become 1 minus x square by 1, base by hypotenuse. And now alpha will then thus become cos inverse 1 minus x square. Alpha here. So therefore sine inverse x is equals to cos inverse 1 minus x square.